3 at negative, almost -1. And these values are just going to get closer and closer and closer to -1 because that's the nature of a horizontal asymptote. Okay, what questions do you guys have about graphing that particular function? Any questions at all? Okay, if there are no questions, we'll keep moving. We'll do the very last one. So first it asks us to find the y-intercept. So we sub in our x as 0. Katie, how am I going to rewrite this equation with a 0 in for x?
Y equals parentheses 1/3. And then to the power of 0, and I don't know if that's plus or minus 2.
It's plus. Good question.
Okay. Then plus 2.
And then what else? There's one more thing.
Plus 1.
Thank you. Okay, now this is going to end up being 1/3 squared plus 1. 1/3 squared is the same thing as 1/9. I'm adding 1 to that, which is going to give me 10/9 in the end. Okay, and 10/9 is just a little over 1. So that is our y-intercept. Thank you, Katie, for helping me out with that. So our point will be 0, 10/9. Okay, and we want to plot that on our graph. So 0, 10/9 is going to be a little bit over 1. It's going to be right there. And I'm going to highlight it so we know which point that was. Then we want to find a horizontal asymptote. Jakeem Gear?
Yes.
So can you help me find my horizontal asymptote here? So the horizontal asymptote is defined by that number. Can you tell me how to write it? Jakeem, you still there?
I asked, could you give me a second?
Oh, you needed a second? I think that's what you said.
All right, could you repeat what you said? My little brother was crying as well. I asked you to give me a second.
That's no problem. Okay, so our horizontal asymptotes are always written in the form y equals, and then the number at the end of the function. So what is the horizontal asymptote going to be for this particular one?
Y equals plus 1.
Yeah, y equals plus 1. Perfect. Thank you very much, Jakeem. All right. So I'm gonna. You did that perfectly. You're good to go. Thank you.
All right. Thank you.
All right. So I'm gonna label that on my graph. All right. So we're gonna have our horizontal asymptote at y equals 1. Okay. We're gonna plot that in there. So we drew a horizontal line at the y value 1. All right, and our very last step is to find the x-intercept, okay? Let's see, Jason, you're here, I think, but your mic probably still isn't working. And same with Tyrell. Lamero, perfect.
I'm here.
All right, so for the x-intercept, we let y equal 0. So how am I going to rewrite this to solve for the x-intercept?
0 equals 1/3. Squared.
So we want to include, it might be hard to see, but it's x plus 2 up here. So the x plus 2 power.
Yeah.
And
plus
then,
1.
Oh, perfect. All right, and then do you remember how we solved this?
Put it in Desmos.
Yeah, so I'm going to use the left-hand side as one equation, the right-hand side as the other, and I'm going to just find that x-intercept. So I'm going to pull up Desmos. Y equals 0 is still this, and I'm just going to edit this so that it's the right function. So x plus 2, oops. No, oh. Plus 2. There we go. And then we have plus 1 at the end. All right, so now we need to zoom out to find this x-intercept. And Lamero, does it look like this blue is... I'm sorry?
You put 11 instead of 1.
Thank you. I think it was Henry that said that. I'm not sure.
Yeah.
But anyway, ways, let's zoom back in. Lamero, does it look like it's ever going to intersect?
No.
No. Okay. And that's because we have our horizontal asymptote at 1. It's like a barrier. It prevents the function from ever crossing that line. So we're never going to cross this. So this has no solutions. Okay. All right, no solutions for that. All right, thank you very much. And now we want to plot some points. So we want to plot some points to the left of the x-axis or the y-axis and to the right of the y-axis. So I'm going to do maybe -2, -1. I probably should do more points to the left because we're already super close to the horizontal asymptote. I'm going to do -3, -2, and -1, and then +1. Okay. So I'm going to just sub these values into my calculator. All right. So my function was 1/3, and then it's going to be to the -3 plus 2 power, and then add 1 to that. So I should get 4 here. I'm going to do it again to the, this time it's -2 plus 2 as the exponent, and then add 1 to get 2. All right, and then at -1, I have 1/3 to the -1 plus 2 power, and then add 1 to that. So I get 1 and 1/3, which is really just 4/3. And then lastly, we have 1/3 to the 1 plus 2 power, and then add 1 to that. And let's see if this gives me a fraction. 28/27. So like super close, not quite 1. All right, so I'm going to plot these points. I'm going to go left 1, 2, 3, and then up 1, 2, 3, 4 for my first point. I'm going to have a point at -1, 2, +2, point at -1, and then 1 and 1/3, and then a point at +1, and it's really close to 1. So I should get my exponential function decaying like this. Okay. All right. So this was the process for graphing that last exponential function. What questions do you guys have about that particular graph? Okay, if there are no questions, I will post this completed document. Actually, I'm pretty sure it's already posted, maybe. Yeah, I think it is. I'll post the completed document on Canvas, and you guys can copy everything down. It should already be up there from yesterday. But so this side was decay. We were just graphing decay functions. This side was graphing growth functions. And it's the exact same process. Growth functions just move up from left to right, and decay functions move down from left to right. Okay. So I'm going to set this to the side, and we're going to look back at our around the world from yesterday. So the around the world document looked like this. Okay. And I want to go through at least one problem with you guys before you go. So there was one that I saw yesterday, and it's just different than all the other ones we've done. So the one I want to start with is number 7. So if you want to go ahead and write this down, then you at least have one solution for your around the world when you work on it. Okay. So in number 7, it says, and I can pull up, let me just go ahead and pull up number 7 on our activities so that maybe it was here. Yes. So that you guys can see the problem in case you don't have it pulled up. Okay, so this first document has both English and Spanish, and it's just the questions. This document has the questions, and then there are answers to the questions. At the top, it's an answer to a different problem, not necessarily the problem that you're given on the sheet. So I wanted to work with number 7. Okay, so it says the number of bacteria present in a Petri dish can be modeled using the function. Let me move this to the side. If I can, of course, it's not going to let me. I need this thing to go away. This is just going to move the tab. Oh my goodness. Y'all, I hate teaching online. This is just the worst. All right, here we go. Okay. So it says the number of bacteria present in a Petri dish can be modeled using the function, and it gives us a function, n equals a times the base e to the RT. This is different than anything we've done so far, okay, because they give us the base as an e. All right, we talked about this yesterday, being e being a natural number. N is going to be the number of bacteria present in the dish after T hours. All right, so if we were doing our FIRT, N is our final value, okay? It says the experiment starts with 50 bacteria, so 50 would be our I. And the population increases by 30% each hour. So my rate would be 0.3 or 30%. Okay. And our time, it says how many bacteria will be present after 12 hours. So we're looking for this value. Okay. So when we set up our equation, we're not going to use the traditional equation we've been using. We're going to use this one right here. Okay. So N was what I'm looking for. So I need to leave that one alone. All right. A is my initial amount, okay? So I'm going to put 50 in for my A. E is the base, and E is a number, so I'm going to keep it the same. R will be 0.3 because that's my rate, and then I'm multiplying it by 12 hours. Okay, so when you are looking for this, you can do it. Let me show you on Desmos, since I'm assuming a lot of you don't have graphing calculators available. You can get one from the school if you want one. If you need information on that, please let me know. So I'm just going to type it in here, 50, and then I'm putting my base E, okay, and then I'm raising that to the power of 0.3 times 12. Let me move my thing out of the way. All right, and it's just going to calculate that number for me. All right, so my N should be equal to, so my equation was N equals 50, E to the 0.3 times 12, and it asks, does the question ask for the final amount or the time? This is asking for our final amount, and our answer is going to be 71.67 bacteria. Okay, so then what I would do is I would go through and I would look for that 71.67 at the top of the cards. I'm just going to scroll through real fast. Nothing up there, so I'm going to go to the end and work my way back up. 11.